Hey, Science 30s, and welcome to our second part of our three-part discussion about organic compounds. Today, I want to discuss alkanes, or I guess alphaics, which are divided into three categories: alkanes, alkenes, and alkynes. Last time, I discussed aromatics, which are hydrocarbons, which are arranged into ring structures, like benzene or polycyclic aromatic hydrocarbons, or PAHs. Today, I want to discuss the chained hydrocarbons, which are going to be arranged in chains of up to in our purposes for our purposes up to 10 carbons in length. Before we get into the differences between alkanes, alkenes, and alkynes, I want to go over some organic nomenclature with you first of all. First of all, there are going to be four types of formulas we're going to be dealing with in this unit. You're all familiar with a molecular formula. So in this case, I've got a substance up on the board called butane, which has a molecular formula of C4H10. You can also write that as a condensed formula, which basically allows you to see where the atoms are arranged in relation to one another. In this case, I've got a chain because this is an alkane, hence the name butane at the end there. So this is a 4-carbon chain hydrocarbon, what we're dealing with here. So it's got basically a carbon, another carbon, another carbon, another carbon, all arranged in a row. The first carbon has 3 hydrogens attached to it. The second carbon has 2 hydrogens attached to it. The third carbon, has 2 hydrogens attached to it. And the fourth carbon has 3 hydrogens attached to it. Hence the condensed formula of CH3, CH2, CH2, CH3. Kind of a weird name because it's not a condensed formula, but it's more condensed than the structural formula, which is another way to represent that structure. Here you've got all the bonds that are related around the carbon. So I've got my CH3 that's represented by a carbon with 3 hydrogens attached to it, each of the lines indicating a single bond. Remember, the magic number for carbon is 4. There should be 4 bonds attached to any carbon atom, because atom will bind up to 4 bonds to basically fill all of its binding sites. So in this case, I've got 1, 2, 3, 4. That carbon is attached to 3 hydrogens and the carbon beside it. The carbons in the middle are attached to 2 hydrogens and the 2 carbons beside one another. That's why our number drops to CH2 in the middle of my condensed formula. And then on the outside, you're going to see again, when you get to the end of the chain, 3 hydrogens on that last carbon, and that carbon will be attached to 1 carbon that's beside it at the end of the chain. So that's sort of how a structural formula looks. The ones that I like to use for this unit are called skeletal, or are also known as line diagrams. Skeletal formulas are basically you have a line to represent each of the bonds. So in this case, now these dots don't have to be there. I've indicated the dots here to indicate where the carbons are, but you can see that this carbon represents that position there, this carbon represents that position there. That's my third carbon, that's my fourth carbon. And each one of the lines represents a single bond. You don't have to draw the carbons, and if there's any hydrogens attached to the carbons, they're automatically assumed to be there. So all I have to do is draw 4 lines to represent a 4-carbon chain alkane, in this case, which is butane. And I'll be giving you more examples of that as we go through today. So those are the 4 types of formulas we can use. We should also be familiar with, and by the way, all the prefixes I'm about to give to you, remember, page number 9 of your data booklet, all your information about organic chemistry is on that page to help you out with this section of the unit. The first prefixes that you need to be familiar with are the number of carbons that are in the chain. So if I've got a 1-carbon chain, the prefix would be methyl. If I have a 2-carbon chain, it's going to be ethyl. 3-carbon chain is going to be propyl. 4-carbon chain, butane, C4, that's butyl. So you can see where the butane comes from in the name butane. 5 is more familiar now: pentyl, hexyl, heptyl, octyl, nonyl, decyl. So once you get past the 4 mark for your carbons in a chain, 5, 6, 7, 8, 9, 10 are very similar to the prefixes you would have learned back in grade 9 when you were doing molecular compounds. And those prefixes are also going to play a role in this naming of these molecules as well. The methyl to decyl are going to be used to represent the number of carbons that are in the chain, but there are going to sometimes be side chains in these main chains. And the side chains are going to maybe have more than one. There might be more than one, or there might be 2 or 3 or 4 or 5 side chains of a particular configuration of carbons. And those have to be indicated by either mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, which you're very familiar with if you remember how to name your molecular compounds back in the day. For example, carbon monoxide, carbon dioxide. Just so you're aware, mono doesn't really get used at all in organic chemistry. Pretty much, we need to have at least two of the same side chain in a alkane in order to then use di or tri if I have three. And I'll explain all of that as we go through today. So that's basically a little bit about the nomenclature. Again, everything I've discussed is basically on that page number 9 of your data sheet. Please take a look at that again to help you out. And I'm going to now basically break down the differences between the 3 types of aliphatics, alkanes, alkenes, and alkynes, and the differences between them. The main difference is alkanes only have single bonds, alkenes have a double bond, and alkynes have a triple bond. That's really the only difference between them, and I'll basically show you how to indicate that here in a couple of seconds. But let's start off with alkanes. Alkanes have a generic formula that is CN H2N plus 2. That's the generic formula for all alkanes. So let's take a look at butane. We just talked about butane a couple seconds ago. Its formula was C4H10. Does that formula match the generic formula for an alkane? Well, let's take a look. If Cn is now C4, that means that 4 is going to be my N value. So I'm going to basically take 2N plus 2 would be 2 times 4 plus 2 is going to give me 10. Hey, guess what? I know that that's an alkane because it's got that generic formula. Just to let you know, alkenes, which have the double bond, are going to have the generic formula CnH2n. So if I had a substance that had this configuration, C4H-N, which now fits the CnH2n formula, generic formula, I no longer have butane, I have now butene because it's an alkene. If I had a triple bond in that chain substance, now I've got a generic formula of CnH2n minus 2 because I'm losing hydrogens because of the extra bonds between the carbons. So that would give me a generic formula or a formula for the butane derivative with a triple bond of C4H6. Again, 4 is my N value. 2N would be 8 minus 2 would be 6. So this is no longer butane or even butene. This would be butyne. So basically, the suffix of the molecule's name indicates whether it's an alkane, an alkene, or an alkyne, and that indicates whether there's only single bonds or a double bond or a triple bond in that chain. And I'm going to get to more examples of that here in a couple seconds. But for now, let's just talk about alkanes. So on the note page that you've got, or on the notes that you're on right now, I've given you an example here of one. I've got that as it's a condensed formula of CH3, CH2, 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 CH3. Let me draw that as a skeletal diagram to make it easy. I've got 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons. There's my skeletal diagram of that alkane. How do I know it's an alkane? Well, if I look at my numbers, CH3, CH2, 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 CH3, to me, when I see that, in my mind, I know that they're all going to be single bonds because each carbon is attached to 4 other atoms. The middle carbons have 2 hydrogens and attached to 2 carbons on either side of them. That represents all 4 bonding sites. So I know that that's an alkane. If I were to see an alkene there, it would look something like this. I might see something that looks like this. Instead of having CH2s all the way through, I might have 2 CHs in there. That indicates that there's a double bond between those 2 carbons right there. And if I had a triple bond, what I would see is this. I would see a couple of C's that have no hydrogens beside them at all in the condensed formula, indicating that there's a triple bond between them The fourth bonding site now is occupied by the carbons beside them. There's no room on these carbons to bind to any hydrogen because there's in fact a triple bond between them. So by looking at the condensed formula, you can tell a lot about a hydrocarbon, aliphaic hydrocarbon, and what the bonds are in there. But looking at this molecular or this condensed formula, I can also see that it is C5, and I've got 5, 7, 9, 12 hydrogens. So I've got C5H12. Does that fit into my generic formula for an alkane? Let's take a look. 5 is my N value. That's 2 times 5 plus 2 is going to give me a value of 12. You betcha. That's an alkane. If it was an alkene, it would be C5H10. If it was an alkyne, it would be C5H8 because of then the generic formulas for each of those. If you're a little bit confused about the generic formulas, be aware they are listed right here on the top of the chart, and it gives you the generic formulas all there on your data sheet, so you don't have to memorize them. You just have to be able to use them and identify when you see these substances. So in the case of this, I know that I've got 5 carbons, all right? So I'm going to use pentyl as my prefix. I know that it's got single bonds, so I'm going to use an ane on the end because it's an alkane, not an alkene or an alkyne. I simply get rid of the YL, and I put the 2 together, and I'm going to get myself pentane. So that substance that was on that page right there is basically pentane. Pretty straightforward. Next page has just got some variations on that. You can see that I can either have them as, I have some molecular formulas, there's some condensed formulas, but you can see the general trend. The number of carbons is basically going to determine your prefix. That's off that list of prefixes I gave you on the previous whiteboard. So 3 carbons would be propyl, propane, 10 carbons would be decyl, decane. I've got 6 carbons on the next one, hexane. You get the idea. Single carbon on the 5th one, a CH4, that's going to be methane, which again, you're pretty familiar with. Methane is a greenhouse gas. That's how you get the name methane, because it's methylane, well, it's going to be methane there. What are some of the condensed formulas for these? Well, I did a couple of condensed formulas for you already. You can see these ones on the notes, but again, if I was drawing a condensed formula for butane, pretty straightforward. It's going to be CH3, CH2, CH2, CH3. That's going to be my condensed one for butane. Octane, I just need a few more. CH3, CH2, 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 CH3. By the way, the condensed or the skeletal formulas for each of these, 1, 2, 3, 4. This is octane, so this is going to be 1, 2, 3, 4, 5, 6, 7, 8. There's my octane skeletal formula. And the last one is heptane. Well, that's easy enough. Let's just fix that one up. Let's get rid of one of these, and we'll just bring this together. And then I'm just going to get rid of one of these. And now I've got 1, 2, 3, 4, 5, 6, 7. That's heptane. Again, all single lines indicating that there's only single bonds between each of those carbons. Okay. Where it gets more confusing, though, is if you have straight lines like this, it's really easy. But sometimes you're going to have what are called side chains. And you can have some of these substances will form side chains that basically branch off the main chain. So I'll give you an example. There is an example on your notes right over here, which looks like it's got 5 carbons, but there's a side chain off of the 1. I'm going to draw that as a skeletal diagram. So I've got 1, 2, 3, 4 carbons on that main chain over there. And then I've got a single carbon off to the side. So let's just count these off. I'm going to circle them just so you can see them. There's my 4 carbons there, and there's my 5th carbon on the top. That's indicating that I've got that would be the skeletal version of that diagram that's on that page right over there, that structural formula that's been drawn there. So how do I name this? Well, when you've got side chains, you have to look for the longest chain. The longest chain is going to be your main chain. In this case, I could either draw the main chain as this, or I could draw the main chain as that. In either case, I'm going to have a main chain of 4. Let's keep these simple. I'm going to make this my main chain, and you're going to see that I'm going to number my carbons. I always want to number my carbons to know where my carbons are in the chain. And if I've got a side chain, I want to make sure that I number that molecule so that the side chain has the lowest possible number. So I could have counted 1, 2, 3, 4 in that direction, but that would put my side chain at a higher number. It would put it at 3 rather than 2. So in this case, there is a right way to count from. In this case, it's to make that side chain on the lower number carbon. So what I've got now is I've got a main chain of 4 carbons. Okay, it's an alkane. There's no double bonds. So I know I've got a main chain of butane. My main chain is going to be a butane molecule. Now I got to find out about my side chain. Well, my side chain has only 1 carbon on it, and it's at the 2 position. It's on the number 2 carbon in the main chain. So that's going to be called 2-methyl butane. 2-methyl butane is what we have there. That's how I named that substance. Okay? Give you a couple of other examples here. It can get more confusing than that. This next page has got a great example on it. This is a real bugger of a molecule here. I'm going to draw this one out as a skeletal as well, just to kind of help you out. So I've got essentially a top chain that has 4 carbons. So I'm going to go 1, 2, 3, 4. That's my top 4 carbons on that diagram. And then it looks like I've got 3 2 carbon subchains coming off the bottom of that. So I'm going to go 1, 2. In this case, I'm going to go 1, 2, and I'm going to go 1, 2. So each of these, so here's my 4 carbons on the top, like so. And then I've got my 3, what look like 3 2 carbon subchains coming off the bottom. Well, if you look at this diagram, and you can pause the video and kind of run numbers for it right now, there's a lot of variations that you could potentially name this as. This could be 2, 3, oh, by the way, I didn't get to this, sorry. If there are multiple side chains on the on a alkane, you do have to indicate them using the prefixes. So if I've got, like in this case, I've got three potentially ethyl groups, and I would have triethyl if I had 3 ethyl groups, or if I had 2 methyl groups, or I would be dimethyl. I'd have to indicate that as well. If I've got multiple side chains that are different configurations, maybe I've got a methyl group, an ethyl group, a propyl group, those side chain groups are going to be named in alphabetical order in the molecule. So if I had ethyls are always going to be named before methyl groups, and methyl groups will always be named before propyl groups. Butyl groups will always be named before ethyl groups. It's not based on the length of the side chain, it's the alphabetical arrangement of those side chains. So there's a lot of ways you could potentially name this, and you can run the math on this. I mean, this could be, in theory, 2,3-diethyl hexane. It could be 3-methyl-4-propyl hexane. It could be 4-ethyl 3-methyl heptane. The question is, which one is it? Well, again, the rule is when you're dealing with a molecular compound, an aliphaic, you got to find the longest subchain, or the longest main chain. So I got to find out where in this diagram I'm going to get the most number of carbons. So I could go 1, 2, 3, 4. Well, that isn't going to be long enough. 1, 2, 3, 4, 5, 6. Okay, well, 1, 2, 3, 4, 5, 6. Oh, 7. There we go. I've got a main chain of 1, 2, 3, 4, 5, 6, 7. So it's going to be a heptane. Those hexanes are not going to be right. Now I have to confirm which order I got to count from. Am I going to count from right to left or left to right? Again, the rule is I want my subchains to have or my side chains to have the lowest numbers possible. If I count from this side, it's going to be 1, 2, 3, 4. If I count from the other side, it's going to be 1, 2, 3, 4, 5. I'm going to take 3, 4 over 4, 5 because those are lower numbers. So I know this is position 1, position 2, position 3, position 4, position 5, position 6, position 7. So I know I've got heptane. That's my main chain. It's going to be the heptane. Now I got to find out what my subchains are. Well, I've got a methyl group here because I've got 1 carbon all by itself over there. I've got a ethyl group over there because I've got 2 carbons over there. So I know my ethyl group is going to be on the 4th carbon, and I've got my methyl group is going to be on the 3rd carbon. So I have to name them. So I could name it 3-methyl 4-ethyl, but remember the rule is the side chains are named alphabetically. So ethyl is going to become before methyl. So I'm going to put 4-ethyl 3-methyl. Okay, so that substance is going to be 4-ethyl 3-methyl heptane. So again, it's not based on the numbers, the orientation of the side chains, or even the size of them. It's based on alphabetical order. That's the way that they're just listed in organic chemistry. Ethyls always come before methyls because of alphabetical arrangement. That's the way it happens. So it has nothing to do with the numbers or the length of the chains, how you arrange them. It's always based on alphabetical ordering. And in this case, I've only got two side chains. I got a methyl group here, an ethyl group there. There's not more than one ethyl group, so we're not dealing with a diethyl situation or more than one methyl side group. We don't have a dimethyl situation going on. That makes it easy. All right, this next page is all about you now. See if you can figure out these ones on your own. See if you could actually draw these as skeletal formulas on a piece of paper. Give it a shot. There's no key in the notes, so if you're following along at home, this will be a good opportunity to pause the video and see if you've actually understood how to actually name alkanes. Give you a couple seconds to pause that video, and I'm going to start talking about them right now. Okay, first one is a 2-methyl pentane. So I got a pentane is my main chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Position 1, 2, 3, 4, 5. Let's do that. My methyl is on the number 2 carbon. There it is. There is a 2-methyl pentane. What would be 2-methyl butane? Very simple. It's a shorter subchain, but it's going to look like that. Here's my butane main chain, 1, 2, 3, 4, because butane is a prefix for 4. I've got a methyl side chain off to the side on the 2 position. We're good to go. What about 4-propyl octane? All right, well, let's go to octane. Octane's got 8. 1, 2, 3, 4, 5, 6, 7, 8. I've got a propyl group, which is going to be 3 carbons on the 4th carbon. So 1, 2, 3, 4. There's my 4th carbon. And I'm going to have a side chain of 1, 2, 3. So there is my 4-propyl octane is what that one is. The next two have multiple side chains. I've got 2,2-dimethyl propane. Okay, well, propane is my main group. Propane has got 3 carbons. So 1, 2, 3. There's my propane main chain. And then I'm going to have 2 methyl side groups, dimethyl. Both of them look like they're on position 2 because it says 2, 2. So the 2, 2 refers to the position of both those methyl side chains. And because there's 2 of them, I have to label that as dimethyl. But I also have to indicate the position of both of them. In this case, they're both at the 2 position. Really, if they're side chains, that's the only place you can have a side chain in a propane main chain. Because if you have it at the end, it would just make it butane. So there's only one position for any side chains on a propane side chain. So we're just going to do this. 1, 2. Almost looks like an X. But that's basically 2,2-dimethyl propane. The last one is a big one. 2,3,6-trimethyl 4-propyl octane. Okay. Main chain again. I'm always going to draw that first so you can see the trend that I'm doing. 1, 2, 3, 4, 5, 6, 7, 8. There's my octane. I'm going to start from left to right. I got position 2. There is one of my methyls. Position 3. That's my 1, 2, 3rd carbon. I've got 4, 5, 6 as my last one. So there's a methyl group on number 6 as well. And then I've got a propyl group, which is going to be 3 carbons on the 4th octane, or on the 4th, carbon. So 1, 2, 3, 4. There's my propyl. 1, 2, 3. So that is going to be 2,3,6 trimethyl 4-propyl octane. There you go. That's how you basically work with alkanes. Quickly review. Watch this video right here. It's going to walk you through alkanes, how you name them, all that good stuff. Give it a watch. Definitely a lot of stuff coming at you in this lesson, but this will certainly help you hopefully clarify anything that maybe I couldn't clarify for you in the video. All right? All right, let's talk about alkenes and alkynes now. We'll finish up the lesson on those two. Alkenes, again, are aliphatics that have a double bond at some point in the chain. They've got the generic formula CN H2N, indicating that somewhere in the chain there's a double bond. When you're naming them, you have to indicate where the double bond is, and alkynes, you have to indicate where the triple bond is. So in this case, the side chain doesn't take priority for numbering. In this case, you want to name, you have to get the bond, the double or the triple bond, as low as you can get it. So for example, if I have 1, 2, 3, 4, 5, I've got an alkene, it's pentene. I'm going to put a double bond there. There's my double bond to indicate I got a double bond on that. So this is no longer pentane, it's pentene. 1, 2, 3, 4, 5, pentene, because it ends in E-N-E, pentene. What's the designation of the double bond? Well, I could count it 1, 2, 3, 4, 5, or I could count it 1, 2, 3, 4, 5. In this case, this is the first carbon. That's the lowest carbon I hit is carbon 2. So this would actually be pent 2 ene. So you have to indicate in the middle of the molecule name the position of the double bond. If I were to write down pent 3 ene, that is wrong because I'm going 1, 2, 3. If I'm counting from this direction, that number is too high. Again, the double or triple bond takes priority in when you're naming alkenes or alkynes. And in fact, it will take so much priority that when you start having side chains, you would actually place side chains at higher numbers if it meant that the double or triple bond is at a lower number in the molecule. So the priority for the numbering arrangement in a alkene or an alkyne, even if they're branched, is all predicated on the fact that the double or the triple bond has to have the lowest possible number. Let's give you a couple of examples. So here I've got CH3, CH, CH2. I can tell this is a different configuration than an alkane, because in theory I would see CH3, CH2, CH3. That would be propane. But here I've got 3 C's, which is my N value, and I've got H's, 3 plus 1 plus 2 gives me 6. So this is C3H6. Well, does that fit my generic formula for an alkene? You bet you it does. It's going to be, N is going to be 3, 2N is going to equal 6. We're good. The only thing is I need to know where my double bond is. In this case, the double bond is going to be between these two right here. That's where my double bond is going to be. So technically, that's going to be my 1 carbon, 2 carbon, 3 carbon. If I was to draw this as a skeletal, it's going to look like that. So I have to give it the special name, in this case, prop 1 ene. There it is, prop 1 ene is what that would be based on what I just discussed. And all the details are on the slide there if you want to give it a watch. There you go. Let's name a couple of others. I got CH3, CH, CH, CH3 is what I've got next. I can tell that my double bond is going to be between my 2 middle C's in that molecule. Again, it's a four carbon chain. So that's my skeletal diagram. I know that's carbon 1, carbon 2. My double bond is going to be right there. That's my skeletal diagram of it. Well, because the position of that double bond starts at 2, this is going to be 4 carbons, so it's but 2 ene. That's how I would name that one. The next one here has a side chain. Now it's going to get a little bit more interesting. We got to find out where the side chain is and where the double bond is, and that's going to have some naming consequences for us. So I've got a 5 chain on the top. 1, 2, 3, 4, 5, which is that configuration right across there. And there looks like there's a side chain. I'm going to put the side chain facing up. Even though the side chain on yours is facing down, that's still that side chain that's facing down. I can also tell that at the end of the molecule, I've got a CH-CH2 arrangement at the end, which means that my double bond is most likely going to be there. Not most likely, it's going to be there. So that's where my double bond is. Now the question is, how do I name it? When we talked about alkanes, the side chain took priority. That's out of the window now. The bond now takes priority, so I have to name it from this side. If I went from the other direction, I would have a lower number for my side chain, but I'd be breaking the rule of naming alkenes, which is the double bond has to have the lowest possible number in the molecule. So in this case, I'm going to have a 5 chain, which is going to be pent 1 ene. That's my main chain. My side chain has 1 carbon. It's at the 4 position. So that's going to be 4 methyl pent 1 ene would be that molecule there. And again, one more. Try these on your own before I show you on the board. Pause me. Try to see if you can name those or actually draw those ones out. Pause me right now, and I'm going to give you the answers right away here. So I've got 4-ethyl hex 3-ene. Okay, so my main chain is going to be a 6-carbon main chain. So I'm going to go 1, 2, 3, 4, 5, 6. My double bond apparently is at the 3 position, so it's going to be 1, 2, 3. Double bond starts at the 3 position. That's my 3rd carbon there. 1, 2, 3, 4, 5, 6. Again, naming your carbons, great idea, or not naming them, numbering your carbons. Great idea in these diagrams to see where you're at. Now my methyl group's going to be on the 4 carbon, which means that it's going to be right there. There's my side chain. Got myself my, oh, sorry, it's not a methyl group, pardon me. It's going to be an ethyl group, so it's going to be a 2-carbon side chain. It's going to look something like that. Get rid of that 4 just so you can kind of see. Now that I've named it, numbered it, I can kind of get rid of my numbers. That's going to be a 4-ethyl hex 3-ene molecule. Last one's got 3 side chains plus a double bond. I've got an octene main chain, 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. I've got my bond at 3, 1, 2, 3. That's where my double bond is going to be. I'm counting from this direction, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to do my dimethyls. I got 2 methyl side groups at 4 and 7. 1, 2, 3, 4. There's one of them. 5, 6, 7. There's my other methyl group. And ethyl is going to be at the 6th position. That gives me my ethyl side group up there. That is 6-ethyl, 4,7 dimethyl oct3-ene. Mouthful. All right. Final one, alkynes. Alkynes, same rules apply that apply to alkenes, except now you're dealing with triple rather than double bond. So you have to indicate that there's a triple bond in your diagrams rather than a double bond. The generic formula for alkynes is going to be CnH2n minus 2. So for example, if I had propine, propane would be CH8, propene would be CH6, and propyne would be CH8, sorry, let me try that again. Propane would be my lord, it's been a long day. Propane is going to be C3H8. Easy for me to say. Propene is going to be carbon, it's 3 carbons, so C3, H6, that would be propene. And then propyne would be C3H4. Again, it would be following this one. 2N, so this would be 6 minus 2 would be 4. So that's going to be propyne. So this is propyne. After I completely butchered that. Now I'm not indicating what the positions are, but technically, you know that because there's only 3 carbons. There's only 3 carbons in a propane main chain. These are all going to be prop1-ene, and this would be prop1-ine, because that'd be the only position for the double or the triple bond, respectively. Naming rules apply. Let's take a look at a couple of examples here. This one up on the board here, I got CH, C, H2, CH3. So I can see the triple bond is between my 1st and 2nd carbon. I got a 4 chain, so I'm going to go 1, 2, 3, 4. My triple bond is going to be here, and that is going to be but1-ine is what that's going to be. Next one down is going to be 1, 2, 3, 4, 5, 6 carbon main chain. 6 carbon main chain. So I can draw my 6 carbons in. 1, 2, 3, 4, 5, 6. I've got a triple bond, it looks like, between carbons 2 and 3. So this is going to be 1, 2, 3, 4, 5, 6. So this is going to be hexyne, but I have to indicate the position of the double bond. It's going to be hex2-ine. Try these ones for yourself. On the bottom here, try these ones by yourself. See if you can name and get those skeletal formulas. Pause the video. See if you're following along and getting this stuff all the way. And here are the answers. Pent2-ine. I got a 5-carbon main chain. 1, 2, 3, 4, 5. My position of the triple bond is going to be after the 2nd carbon. There's my triple bond right there. The methyl group is going to be 1, 2, 3, 4. Remember, the side chain does not take priority over the double or the triple bond. In the case of an alkyne, a triple bond, you always name the triple bond with the lowest possible number. Then you figure out what the side chains are going to do after that. But that right there is a skeletal formula for 4-methyl pent-2-ine. And the last one, which has multiple side chains, I've got 2 propyl side chains on a non-9, which is going to have 9 carbons. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, and again, I can number them. I'm not numbering them. I'm getting kind of a little lazy here, but again, I don't blame you for numbering your carbons. The triple bond is going to be on the third carbon, so my triple bond is going to be between carbons 3 and 4. It starts on carbon 3, that's why it's indicated as non-3-ine. And then I've got 2 propyl side groups, looks like on the 6th carbon, so I'm going to have a 1, 2, and a 1, 2 on number 6, indicated by that little thing there. This is indicating oh, pardon me, not going to be 2. Prop is going to be 3. That would be ethyl side groups. There you go. There are your 6,6 dipropyl non-3-ine. Final answer. All right. Take a look. Walk you through all of it. Alkanes, alkenes, and alkynes from start to finish. 10-minute video. Watch it all. Get it all embedded in your head. This is going to be crucial. If you can't name these, it's going to be a long couple of units or a couple of lessons here for you, because it's going to get more complicated after this. So see if you can wrap your head around naming these alkanes, these alkenes, and alkynes. How are you going to do that? Well, here's what you're going to do. You're going to complete a worksheet that I've got the link to below this video in the description, called Naming Aliphatics. It's going to have a bunch of different condensed formulas, some skeletal formulas, some names that you have to draw formulas for, a little bit of everything, just to see how well you can actually name your alkenes, your alkanes, alkenes, and alkynes. Easy for you to say. I got numb tongue or something today. But there you go. That's basically part 2 of our look at organic compounds. Next day, we're going to take it up a notch. We're going to add something other than carbon and hydrogen into the mix. We're going to start adding halogens. We're going to add some fluorine, bromine, some chlorine, some iodine, your classic halogens that are over on that right side of the periodic table, right beside those noble gases. We're going to be discussing what are called halogenated hydrocarbons. And you may know some of these offenders. You may have heard of something called CFCs, and a little thing that they almost destroyed called the ozone layer. I'll be discussing that next day. So thanks for tuning in. It was a big one today. Play this video a couple times if you have to. There's a lot of material that was covered today, but very important stuff. Thanks for tuning in, guys, and we'll see you next time for halogenated hydrocarbons.